So here's our second example. Again, it's going to be a randomized experiment, but it would work the same way with an observational or a quasi-experimental study. But I wanted to do another example. So we're going to take the role of a psychologist who wants to investigate different types of motivation on performance of clerical tasks. And we're going to kind of expand this example in future chapters. So this psychologist wants to know if you would do better if you were individually motivated. That's, here we have 10 participants that are told they're going to be rewarded or paid based on how many tasks they completed, their own number of completion tasks. And we're going to compare that to another group, which happens to have 12 people in it, who are told that they are going to get rewarded or paid based on how much their whole group finishes in the time allotted. So then we want to know, does motivation affect tasks completed? So we're randomly assigning 10 people in one group, 12 people in another group. Doesn't matter if you're told you're going to get paid on what you do versus you're going to get paid on what the group gets done. Do you want to have a work on your own assignment or a group project? What do you think? Which group's going to be higher, get more accomplished? Which group do you think is going to get less accomplished? Is there an obvious group that's going to do better than the other? You might have a hunch, but really it probably could go either way. So we're going to do a two-tailed t-test comparing these two groups. So the experiment went forward, and we are going to call the two groups self and collective. So in green here, I have the number of tasks completed by each person that was told that they would get rewarded or paid based on their total completed. And then below that, I have the totals for each person that was in the run that said that they get paid based on what the group did. So the research question, does this matter? Are the averages of the two groups the same, or are the averages different? So don't worry about this part. I'm just reading the data into R, but you want to know that there are two variables. There's motivation that tells us which group they were in, and task done that says how much they accomplished. So I'm going to do my exploratory data analysis first, always. I'm going to summarize with a mean and standard deviation for each of the groups. So motivation is what I'm going to group by. That's either collective or self-motivation. They get paid on what the group did or what they themselves did. And I'm going to summarize how many tasks they had done at the end of the time period. So for the collectively motivated people, they averaged 7 3/4 tasks done. Now, I don't know if this was filing files or licking envelopes. I don't know if this was over a day, a week, a month, an hour, 5 minutes, but they got 9 3/4 done. In the self-motivated group, they averaged 13.6. Looks like self-motivation tends to get more accomplished, at least descriptively wise. So summary statistics, informative, but don't maybe tell the whole story. I also want to point out the spreads. In the collective motivation group, the spread was almost 4 versus in the self, it was just over 2. Do these two groups have the same spread? Maybe not. Let's make a plot. Visually, it's a lot easier to assess with a plot. So the lines on the box plot, remember, those are not the means, those are the medians, but they help us judge center. So in the collective group, it does in fact look like they got less accomplished than the self group. But the spreads are not the same. You can look at those boxes, and in the collective, the box is bigger. There's more spread out. In the self group, it's a lot more compressed. Is a t-test appropriate in the situation where we have more spread and less spread? We have a bigger group of 12 and a smaller group of 10. We might be there in time where we need to be concerned. So before we decide if we should do, homogeny variance is okay, the pooled variance test, or spreads are not the same, Welch's separate variance test, we better test the spreads with homogeny of variance Levene's test. So code looks like before. We're going to use CAR, companion for applied regression, Levene's test, and we're going to have our formula. The formula is always the continuous dependent variable first, followed by the two-group categorical factor that says how the two groups are defined. Data equals dot to flow from above, and better change our option so it's mean instead of median. Here we go. We get Levene's test for homogeny of variance. Yeah, we changed the center to mean. That's important. If you misspell center equals mean, it will say center equals median. It will not give you an error message. Okay, so our groups, the degrees of freedom are 1 and 20. Yay, whatever. There's our F value. It's 4.8. Yeah, so what? Let's look at our P value. This common way to write P value in R, it's PR, and then in parentheses, greater than F. So this is the probability we would get something bigger than this F value. Now, here's our P value for Levene's test. Notice it gets a little star. Levene's test, the null hypothesis is nothing's going on, normality or homogeny of variance is fine. We've got a small P value. Remember, low, null must go. P value low, null must go. So nothing going on, it's out the window. We now know that there is indeed a violation of homogeny of variance. So not only, this is telling us that the two groups have different spreads. We also saw these two groups were small and unbalanced, different sizes. Small, 10 and 12 are fairly small groups, and they are not the same number. So we got 3 hits here. We got violations of homogeny of variance, small group sizes, and unequal group sizes. The traditional pooled variance t-test is probably not your best option. So we're going to do the Welch's separate variance test. And to do that, our code for the t-test is going to be exactly the same, except for the last bit. We're going to say var.equals false. Not going to have the variances be equal because we have evidence of a violation of homogeny of variance as assessed by Levene's test. So, separate variance test. Looks the same as before. We're going to start with our data set, which we're calling df2 long because it's the second example. We're going to pipe that into t.test, base our command, give it a formula, which is the dependent variable, how many tasks they got done, and then tilde wave, the two-level grouping variable that says which type of motivation they had, data equals dot to flow the data set from above, and here's the part that makes this the separate variance test. We have to change it, not the default, to var.equals false. Okay, run that, and notice that the output doesn't say t-test, two-group t-test. It says Welch's two-sample t-test. And I want to point out when we do Welch's, those degrees of freedom, decimal, decimal. That's okay. When we do var.equals false, in order to do this separate variance Welch's t-test, we should get degrees of freedom for our that are a decimal number. That's part of Welch's adjustment. And against Welch's is doing an adjustment to the degrees of freedom to help make the p-value more accurate in the presence of those violations of homogeny of variance, violation of large groups, violation of equal size groups. Now we get a confidence interval for the difference between the means as well as reporting the actual group means. So t-test, negative value. Now I do want to point out when we're doing t-test comparing two groups, the t value could be positive or negative, and the positive or negative sign on the t-test merely is a result of the order that you're subtracting in, whether we're doing self-motivated first or collective motivated first. And if we go back to the table, notice collective is first in our table before self. And that's because by default, the groups, collective and self, are usually alphabetized. And C for collective comes before S, self, in the alphabet. So collective, you notice, has a smaller average than self. So if we subtract in the order, alphabetical order, 9.75 minus 13.6, we come up with a negative difference. Now, if we hadn't done it alphabetical, if we'd had self first and collective second when we subtracted, we would have gotten the same number, but it would have been positive instead of negative. So for that reason, when we do a t-test for two groups, we usually do not report the negative sign on the t-test because it only reflects the order of subtraction. Instead, we would usually report the actual means and then the t-value as an absolute value without the negative sign on it, the degrees of freedom, and the p-value. So I want to point out this p-value. The p-value comparing motivation self and motivation collective on tasks completed, p-value is small. P-value low, null must go. So this is evidence against the nothing going on. So we do have evidence that there is a difference. Now, on this sentence I just put here, generically speaking, there is evidence of a difference, but we should also include the direction. And by looking at the means, the summary statistics, we can see that there was more performance, more tasks completed in the self-motivation group, whose average was 13.6, versus the collectively motivated group, where its average was 9.75. So again, when there is a significant effect, you should say which direction, which group's higher, which group's lower. And then we would put our test statistic here at the end. T with its degrees of freedom. Notice T has a decimal degrees of freedom, again, because we're doing Welch's test, because we did not want to assume the variances were the same. So let's write it up. We've got a methods section and then a results section. So in the analysis part of the methods section, we would want to say why we're doing this. We want to test if the performance on this clerical task, mailing envelopes, filing files in alphabetically, I don't know what it is, if that is affected, is it affected or affected? I might have that wrong. So we're going to do an independent samples t-test. Independent samples t-test is the generic term for just comparing two groups. Again, we want to state what is our independent variable, what is our dependent variable. Type of motivation, self versus collective, is our independent variable. That's what we're seeing. If we change this, does it result in an effect on the number of tasks completed? So that's what we think is going to happen. Is there an effect of this on that? We're going to use a t-test to see. Then you talk about your assumptions. Levene's test was used to test the assumption of homogeny of variance to decide if we should do a pooled or separate variance test. I think that's the identical sentence I used last time. And here we go with the results section. Start results, we might want to summarize and eyeball the descriptive statistics. So individually motivated participants did complete more clerical tasks. And then in parentheses, I'm going to put the means and standard deviation, and I'm tucking the number in each group inside this parentheses as well. If you have multiple summary statistics in the same set of parentheses, separate them with commas. Again, summary statistics within a sentence should be in parentheses. So I'm using a sentence to give them the descriptive statistics. Again, with two groups, we can stick this in a sentence. If you have more than two groups, which we will get to in the ANOVAs, you will probably want to make a table when you have more means and standard deviations. So then we're going to talk about that assumptions test we did. Assumption of homogeny variance was tested and evidence was found. Violations were found. Evidence of violations of that homogeny variance were found. Again, this is an F test with 2 degrees of freedom. And so because we found evidence of violations of homogeny variance, we're going to do the separate variance test, or you could call it Welch's test. Statistically significant evidence was found to support the claim that the type of motivation affects performance. So that's just saying, yes, there was a difference. Now, I'm going to say which direction. Individually, motivation does result in a mean of 3.85 additional tasks completed. Now, it's a good idea when there is an effect to say how big of an effect, direction and size. So I've just taken the two averages and subtracted them, the average of 13.60 and 9.75. If you subtract those two, you see how big of a difference there is. Now, is it always going to be that big? Well, in these samples it was, but to give a margin of error, it's a good idea to include that confidence interval in the results as well. So my results will have our t statistic with its decimal degrees of freedom, since this was a Welch's or separate variance test. P-value, yep, it's small, so there is evidence of an effect. And then 95% confidence interval, and in square brackets, the lower and upper ends of that confidence interval. And so the first example we did was using the traditional pooled variance t-test, and it had no evidence of a difference. And in this example, we've done a separate variance test because of the violations of homogeny of variance and imbalanced small sample sizes. And in this case, we saw statistically significant evidence of an effect. Now, I wanted to do both kinds of tests and both kinds of outcomes, but I want to point out that you can get both outcomes, no evidence of a difference, or evidence of a difference. You can get both of those outcomes from both of the types of tests. So, I'm going to wrap up the second video. Next time, we will be covering power and effect size. And that will get us through kind of this generic topics of introduction to inference.